All right, let's get started with the lesson 8 notes. We're going to start off with a number line. And here's 0 right in the middle. I'm going to do a couple just to either side. And I'm going to put a closed circle at -2, and I'm going to shade it to the left. And I'm going to put an open circle at 3 and shade it to the right. Now, let's write this in an inequality. So this right here is saying that x is less than or equal to -2. This one is saying that x is greater than 3. Now, a number can't be both less than -2 and greater than 3. It has to be one or the other. So we would put the word or in between. Now, let's talk about this in interval notation. So this right here means that I'm going all the way to -infinity, and then I'm going to stop at -2. So -infinity to -2, and we put that bracket, that square bracket, because it includes -2. This one means I start at 3 but don't include it, and then I go to infinity. So 3 with the parentheses to infinity. And again, we put the word or in between. Now, let's draw another number line over here. And we're going to kind of almost do the opposite. So I'm going to still put an open circle at 3 and a closed circle at 2, but we are going to shade between them. Okay, so what this means is that these numbers are where x is greater than or equal to -2 and less than 3. But it has to be and, because both things are true. So for example, 1 is less than 3 and greater than -2. Now, another way you'll see this written is like this. Basically saying x is less than 3, and it's greater than -2. So these two things are the same. They say the same thing. Okay? The way that I think about it is x is between -2 and 3. Now, how does this look with interval notation? Well, I'm including -2, and I'm going up to 3, but not including it. So all of this brings us to compound inequalities. Compound inequalities. So let's say I have this. X plus 3 is less than or equal to 2, or 3x is greater than 9. Basically, we're just going to solve these individually. So just like I normally would, I'm going to subtract 3 from both sides. And that gives me x is less than or equal to -1. Or, here I'm going to divide by 3. X is greater than 3. So how would we graph this on our number line? Here's 0. There's 3. There's -1. I'm going to put a closed circle at -1. Shade to the left. Open circle at 3. shade to the right. Do you guys notice how there's some similarities with our shading and circles on number lines as there was in our graphing in the lesson 5 notes? So when it's the equal to, we're including that number, so we fill it in, right? We had a solid line. But when it was just less than or greater than, we did the dashed line because it wasn't including it. So the dashed line is like the open circle where we don't fill it in all the way. So just kind of making some of those connections there. What does this look like in interval notation? Well, this is negative infinity to negative 1, including negative 1, so we put the square bracket, and then, or, not including 3, but 3 to infinity. 3 to infinity. All right, let's try another one. Negative 2x is less than 8, and x minus 3 is less than or equal to 2. All right, so I'm going to divide by negative 2, and when I do that, I'm going to have to flip because I divided by a negative. So this is going to be x is greater than negative 4, and what do I do to this one? I'm going to add 3 to both sides. So x is less than or equal to 5. So x is greater than negative 4 and x is less than or equal to negative 5. What's the other way I could write this inequality? Oh, shoot, not like that. Negative 4, then I have x, so x is greater than negative 4 and less than or equal to 5. Let's do our number line. Do it over here. There's 0. There's 5. There's negative 4. So open circle at negative 4, close circle at 5, and we shade between. Now, what if I do this in interval notation? Negative 4, not including it, to 5, including it. Okay, basic idea, and we shade between, or we go on the ends. And that idea is going to come up again later in this lesson. All right, let's talk about absolute value. What does absolute value do? So let's just do some basic examples here. Let's say I have absolute value of negative 3. That would be 3. Absolute value of 7. Still 7. Absolute value of negative 2 is 2. So what does the absolute value do? It makes the number positive. But be careful. So for example, let's say I have the absolute value of 3 minus 6. Some people might say, oh, I'm just going to change this to a plus, and that makes it 9. No, you have to follow PEMDAS. PEMDAS, PEMDAS, PEMDAS. Now, P doesn't stand for absolute value, it stands for parentheses, but you almost have to think of this absolute value like a parentheses. We're going to simplify as much as we can inside the absolute value first. So this does not become, so this is not 3 plus 6, which is 9. So that's a no. What we do, what we do is simplify. So what is 3 minus 6? It's negative 3. Then it becomes 3 because the absolute value makes that final number positive. All right. You guys, I'm going to give you just a couple simple ones to try just to kind of get the hang of it. So let's say I have 2 plus the absolute value of 2 plus 3 and the absolute value of 2 minus 9. All right, pause the video real quick. Give those two a try. All right, hopefully you were able to simplify those correctly and get 5 and 7. All right, now let's solve some equations that have absolute value. So example 2, let's say I have absolute value of x equals 5. Absolute value of x equals 5. What number could x be? Well, think about what numbers, when I take the absolute value of it, I get 5. Well, x could be 5, or x could be negative 5. X could be 5, or x could be negative 5, because the absolute value of 5 is 5. The absolute value of negative 5 is also 5. Okay? Let's try this one. Absolute value of x equals negative 3. Now, you might be thinking 3 and negative 3, but I want you to actually think about it. If x is 3, what's the absolute value of 3? Not negative 3, it's 3. How about if I put a negative 3 in here? If x is negative 3, right, if I have the absolute value of negative 3, that gives me 3. So is there any number that will give me a negative 3? There is not. There is no solution to this because an absolute value will never equal a negative number. It will only equal a positive number. So this has no solution. All right, let's try another one. Let's say I have absolute value of x minus 7 equals 5. Now, I know what you're thinking. You say, oh, Miss Jackson, that's so easy. It's just 12 and negative 12. Well, let's think about this. X equals 12. That sounds good to me. Okay, I'm just going to write this in the margin. So let's test this out. 12 minus 7. That gives me 5, which is 5. That checks out. Let's try negative 12. Negative 12 minus 7. Negative 12 minus 7 gives me negative 19. Ooh, and the absolute value of negative 19 is 19. Wah, wah. That's a no, right? This is not correct. What you have to understand is that whatever this is, it either equals 5 or it equals negative 5. So here's what you have to do. You have to write two equations. You have to take whatever the whole entire thing is that's in the absolute value, which in this case is x minus 7. And this whole thing either equals 5 or negative 5. So let's try it again. If these are my two equations, add 7, I get x equals 12, or negative 5 plus 7 gives me 2. All right, let's try 2. If x is 2, 2 minus 7 gives me negative 5, and the absolute value of negative 5 is indeed 5. It works. Awesome. Okay, Let's try this one. X plus 6 equals 2. So again, we're going to set up two equations. And what are my two equations going to be? They're going to be x plus 6 equals 2 and x plus 6 equals negative 2. Solve each of them. I'm going to get x equals negative 4 or x equals negative 8. Okay. Let's try these ones. X plus 2, absolute value of x plus 2 equals 7. And absolute value of 2x plus 4 equals 10. All right, pause the video. Try these two on your own. If you're stuck, this is how your two equations should look. I'm taking this whole thing that's in the absolute value. We set it equal to 7, and then the other one we set it equal to negative 7. See if you can do the rest on your own. Okay, hopefully you were able to make your way through these problems, setting up the two different equations each time and then solving them individually. Now, there's going to be a second part to this lesson. I'm going to do it in a separate video just because I don't want this one video running too long. So next up, you're going to watch part 2 of the lesson 8 notes.